So in this exercise 1.1, we have discussed some questions. Now let us discuss the remaining questions. See the next question. What is the next question, my dear children? What is the next question? See next question. A relation or in the set. Fourth one, first Roman, fourth question. First Roman, fourth question. Read that question, my dear Kevin Paul. Kevin Paul, read the question. Kevin Paul, read the question. Have not downloaded the textbook from the Google, Kevin Paul. Previously, I told all of you, please download the textbook from the Google.
Sir, can I read, sir?
Yes, carry on.
Sir, it says the relation R in the set Z of all integers defined as R equals ordered per x comma y, where x minus y is an integer, sir.
Yes, this is a relation defined on the set of integers. Okay, given relation or in the set Z, the set Z of all integers. Defined as R is equal to set of all ordered pairs x comma y such that x minus y is an integer. Okay, Maricita, this is a question. Have you found the difference between the previous questions and for this question? Have you found any difference between the previous questions and for this question? Have you found any difference?
Yes, sir.
Yes, sir.
What is the? Tell me what is the difference, Joseph? What is the difference?
Sir, in set Z, the values are not given correctly, sir.
Very good, very good, very good for your observation. Thank you, my dear Joseph. In the previous questions, domain is given clearly. The elements of the domain is given clearly. Yes or no? The
Yes,
previous
sir.
questions, domain, the elements in the domain and codomain, same domain and codomain are the same sets, and the elements of the domain and codomains are given clearly, but here not given. That is a difference. Okay, so here we have to use our previous knowledge. Okay, my dear children, if one number is an integer, the difference of any two integers is always integer or not? Now let us verify this relation is reflexive, symmetric, and transitive or not. Okay. Now let us check this relation is reflexive or not. Tell me the definition of reflexive relation. Ayush, okay, listen, Ayush, carefully. Blessina, tell me definition of reflexive relation.
Sir, x comma x should be there, sir.
Huh? Tell me the
The
definition.
twin of the number should be there, sir.
Twins should be there. Okay. Here we are not able to find the numbers here. Numbers are not given clearly, directly. In this case, please listen these steps carefully, my dear children. We have to choose a number from the domain. What is the domain here? What is the set? What is the domain here for
Integer,
this?
sir.
Very good. Codomain?
All integers.
Where
Sir.
integer.
Yes. Domain is also integers and codomain is also set of integers. From the domain, let us choose a number, an arbitrary number. First step, remember this one, my dear children. Step 1, we have to choose a number, arbitrary number, not numerical value, just we are choosing a integer. Okay. Step 1, this is step 1. Next step, we have to remember that relation. What is the relation between x and y here? Defined between the x and y, x minus y is an integer. Yes or no?
Yes, sir.
Yes, sir.
X minus y
Yes, sir.
is an integer. Okay. In this relation, in this given relation, we had to write both letters same. Both letters same. Means here we have taken a. Substitute this a in the place of x as well as in the place of y. So, in this statement, x minus y is an integer. Okay. This is a statement. This is a relation between x and y. Yes or no? In this statement, we have to write a minus a. Because we have taken a number from the domain. A belongs to z. So we are writing in the place of x, a minus in the place of y is also a. Okay. After writing these two values, is an integer. Is an integer. Write the remaining part as it is. Remaining part as it is. A minus a is an integer. We got this statement. In the given relation, we wrote a in the place of x and a in the place of y. Then we got a minus a is an integer. Okay, we got a statement. Now we have to check whether this statement is true or false. First, we have to write this statement like this in the given relation. Instead of the different letters x and y, you write the same number. Okay. This implies what we will get here, a minus a. Stains Johnson, tell me, a minus a. What is the value of a minus a? Stains Johnson, a minus a. Krupal, tell me, a minus a. What is the value of a minus a? What is the value of 2 minus 2? Krupal.
Sir, 0.
Yes. 0, 0. Very good. So, one number minus the same number itself, we get 0. So, 0 is an integer. After simplifying these two numbers, we got this statement. A is an integer. So, 0 is an integer. We got this statement. Is this statement true or false? We have to check. Is this statement true or false? 0 is an integer or not?
False, sir.
0 is an integer. Is this statement true or false?
True, sir.
True, sir.
Yes, true statement. We got here a true statement. We got a statement here and we have to check whether the statement is true or false. Okay. If we get to true statement, we say that ordered pair A comma A belongs to R. Ordered pair A comma A belongs to R because the two numbers satisfying the given relation, that is reflexive relation. Therefore, we say that ordered pair A comma A belongs to R. That is point, my children.
Yes, sir.
Yes, sir.
This is the step
Yes,
3.
sir.
In the step 3, we have to check whether the statement is true or false. If it is a true statement, immediately we can write ordered pair A comma A belongs to R. Therefore, we conclude that therefore R is reflexive because twins are there. Twins belongs to the real numbers, relation R. Twins belongs to the relation R. That is why R is reflexive. I will repeat this reflexive relation to check R is reflexive or not. See the first step. In this case, domain, the elements of the domains are not given directly. In that case, we have to choose a arbitrary element, arbitrary number from the domain. Here domain is Z, set of integers. Okay. Second step, after choosing this one, an arbitrary number from the domain, we have to write the relation, the given relation. In the given relation, we have to write same numbers, same letter A and A. In the place of X and Y, we have to write the A itself. So A minus A is an integer. That is the second step. After writing this statement, we have to simplify it. Here we got A minus A. It is a 0. So 0 is an integer. We wrote that remaining part, remaining sentence as it is in the next step. Okay, 0 is an integer. We got this statement. After getting this statement, we have to check whether this statement is true or false. If it is a true statement, immediately we have to write ordered pair A comma A belongs to relation. That is a twins. Twins belongs to relation R. Therefore, we say that R is reflexive. Got this point, my children?
Yes, sir.
Got it?
Sir.
Right. Now, to check R is symmetric. Here, step 1. To check the relation R is reflexive, we have chosen only one number from the domain. Now, to check the relation R is symmetric, we have to choose two arbitrary elements from the domain. So, let A comma B. Let A comma B belongs to Z. From the domain, we are choosing how many elements? How many elements we are choosing here?
Two,
Kevin
sir.
Paul? Kevin Paul.
2, sir.
Yes. What are the two elements? Tell me.
X and Y.
Huh? What are the two elements chosen from the domain here? Kevin Paul.
A and B, sir.
Very good. A and B. Only A and B have taken from the domain. Next, second step, step 2. What we followed in the previous relation, here also we write the same. What is the relation? X minus Y is an integer. Okay, my children. Now, in the place of X, we write A, and in the place of Y, we write B. Okay, A minus B is an integer. In the given relation, or in the place of X, we write A, and in the place of Y, we write B. then we get this statement: a minus b is an integer. Okay. Okay, my dear children, got this step?
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
Yes. Now, step 3. Now, write in the reverse order. Symmetric means what is meant by symmetric? Reverse ordered pair should be there. Yes or no? Reverse ordered pair should be in the relation. Yes or no?
Yes, sir.
Yes. So, in step 2, you have got one statement. Yes or no? A minus b is an integer. In the same statement, just interchange the places of a and b. What will you get if you interchange the places of a and b? What is the statement?
B minus A, sir.
Yes, b minus a. B minus a is an integer. B minus a is an integer. Okay, my children. Now let us simplify. If you take minus common from these two numbers, what will you get? Minus of a minus b is an integer. Yes or no? Minus of a minus b is an integer. Suppose 7 is an integer. 7 is a minus b. Let us assume that 7. A minus b is 7. 7 is an integer. Then its additive inverse. What is its additive inverse? Tell me.
Minus 7, sir.
Very good. Minus 7 is an integer. Yes or no? If 7 is an integer,
Yes,
minus
sir.
7. Yes.
Yes, sir.
Similarly, here a minus b is taken as an integer. What is its additive inverse? What is its additive?
Minus of a
Minus-
minus b, sir.
Minus A minus B.
Minus of a minus b. It is also an integer. We got this statement. Okay. Is this a true statement or false statement?
True, sir.
True
Sir.
statement. So here also we have to check whether this statement is a true statement or not. If this statement is true, we can write here ordered pair b comma a belongs to R. Here we got a comma b belongs to R. We have taken ordered pair a comma b belongs to R means a minus b is an integer. We have chosen an ordered pair a comma b in the relation R. Then it's a reverse ordered pair. Ordered pair b comma a is also in the relation R. Means the relation between b and a also satisfying the same relation. Understood, my children? In step 2, we have chosen and let ordered pair a comma b belongs to R. Okay. This is in the step 2. After taking the second step, ordered pair a comma b belongs to R. Finally, we got conclusion ordered pair b comma a also in the relation R. Then what do you say about this relation? If ordered pair a comma b belongs to R, then it's reverse ordered pair b comma a also in the relation R. Then what will you conclude?
Sir,
It
R
is symmetric, sir.
R is a symmetric. Therefore, R is symmetric. I repeat these steps, my dear children, once. Listen carefully to check R is symmetric. First step, we have to choose any two arbitrary elements from the domain, that is integers. Okay. Step 2, we have to assume that we have to suppose ordered pair a comma b belongs to R. First, we have to assume that ordered pair a comma b belongs to R. Ordered pair a comma b belongs to R means the relation, the given relation, we have to write a in the place of x and b in the place of y. Okay. Then we get this statement: a minus b is an integer. In the step 2, we got this statement. Next, step 3. In step 3, we had to write in the reverse order these two numbers. Here a minus b is there. We write it in the reverse order. So b minus a is an integer. We got this statement. Okay. After that, we have to taken minus 1 common from these two numbers. Then we get minus of a minus b is an integer. So after getting this statement, we have to check. We have to check whether this statement is true or false. Here we got this is a true statement. That is why we wrote here ordered pair B comma A belongs to R. Okay. Here. Who said this? What is the occasion? Occasion. Okay, got this point, my dear children.
Yes, sir.
Symmetry.
Yes, sir.
Next, now what is the next relation?
Transitive,
If
sir.
it's transitive or not.
Transitive. To check R is transitive. To check R is transitive, we follow these steps. Step 1. Listen carefully, my dear children. Follow these steps. Step 1. Here we have to choose 3 numbers like A, comma, B, comma, C belongs to Z. In the domain, integers, set of integers, we have chosen 3 numbers, 3 arbitrary numbers, namely A, comma, B, comma, C belongs to Z. Once, let us go back. In the case of verifying relation R, we have chosen only one element from the domain. Okay, my dear children, remember these steps. In the case of verifying R is symmetric, we have chosen 2 arbitrary elements from the domain. Okay. Now to verify R is transitive, we have to choose 3 numbers from the domain. Okay, my dear children. Step 2. After choosing 3 arbitrary numbers from the domain, we have to assume that ordered pair A, comma, B belongs to R and ordered pair B, comma, C belongs to R. We have to assume that let ordered pair A, comma, B belongs to R and ordered pair B, comma, C belongs to R. Okay, my dear children. So, how do you write this notation in the sentence form ordered pair A, comma, B belongs to R? How do you write in the sentence form ordered pair A, comma, B belongs to R? Means how do you write this notation in the sentence form? A minus B. A minus B is an integer. Okay, my dear children. This is a notation. Ordered pair A, comma, belongs to R. If you want to write this relation in the sentence form, we write A minus B is an integer. Similarly, we have supposed ordered pair B, comma, C belongs to R. Then how do we write this notation in the sentence form?
B minus C is an integer, sir.
Very good. B minus C is an integer. In the given relation, we are writing here A and B. In the second statement, we are writing X and B and C in the place of X and Y. We got 2 statements. Okay. A minus B is an integer and B minus C is also an integer. Okay. Now come to step 3. Now come to the step 3. What should we prove here? What should be proved here? Ordered pair A comma B belongs to R. It's link ordered pair. We have taken like this only. Ordered pair A comma B belongs to R. Ordered pair B comma C belongs to R. Implies that what should be proved here?
Sir, A comma C should belong to R, sir.
Yes, very good. Ordered pair A comma C should be in the relation R. That ordered pair also should be in the relation R. Yes or no?
Yes, sir.
Yes,
Yes,
sir.
Yes. So, how do you write that notation? Ordered pair A comma C belongs to R means, how do you write that notation?
Sir, A minus C is an
Minus C
integer.
is an integer, sir.
A minus C is an integer. Yes or no? A minus C is an integer. Now, here let us consider this is a relation 1, this is 2. Let us subtract second from second equation. Let us subtract 1. So let us write this one. We have to show that C minus A is an integer. Yes or no? Ordered pair ordered pair A comma C belongs to R means ordered pair A comma C belongs to R means we have to show that A minus C is an integer. Yes or no?
Yes, sir.
Yes, sir.
Okay. Here, let us add these two. A minus B plus B minus C. A minus B is also an integer, B minus C is also an integer. If we are adding any two integers, what will you get?
Another
We
integer.
get an integer, sir.
Integer, sir.
Yes, again we get integers. Yes or no? We again just wait a moment, my dear children. Some technical issue arise. Again, I will show you. Now, are you able to see that screen?
No, sir.
Okay,
No,
okay,
sir.
okay. Now,
Yes, sir.
Yes, sir.
Yes,
see, I
sir.
wrote here A minus B plus B minus C. What is A minus B? It is an integer. Yes or no? From the equation 1, A minus B is an integer. What is B minus C? It is also an integer. If we are adding these two integers, what will you get? Is an integer or not? Sum of two integers is an integer or not? Tell me.
Integer, sir.
Yes,
Integer.
sir.
Is an integer. A minus B is an integer. Got this point, my children? A minus B is an integer. B minus C is another integer. Here we are adding these two integers. What will be the resultant number? Is it an integer or not?
Integer, sir.
It is also an integer. That is why I wrote this statement. Let us simplify these four terms. What will you get? A minus B plus B minus C is an integer. Here I am simplifying these four terms by removing the small brackets. I am writing these four terms. A minus B plus B minus C is, I am writing the remaining sentence as it is an integer. Got this step, my children?
Yes, sir.
Yes, sir.
Now, what will you get in the next step? Simplify
Sir.
these four terms. What will you get?
A
Sir, A
minus C,
minus
sir.
C is an integer.
So, minus B plus B gets cancelled. A minus C. A minus C is an integer. Yes or no? We get to this statement. A minus C is an integer.
Yes, sir.
Okay.
Yes, sir.
Yes. It is a true statement. Because it is an integer, it is an integer. By adding these two integers, we get an integer. So it is a true statement. So we are simplifying these statements. Finally, we got a minus c is an integer. It is also a true statement. How do you write this sentence by using the notation? Previously, I asked you question here. Here notation is there. How did you write in the sentence form? Similarly, here sentence form is given. How do you write in the notation form?
Sir,
A minus
comma
B
C
belongs
is
to R, sir.
Yes, ordered pair A comma C belongs to R. That is point, my children. At the step 2, we have taken a link ordered pairs, namely ordered pair A comma B belongs to R and ordered pair B comma C belongs to R. A pair of link ordered pairs were taken and we have to show that the resultant ordered pair, third ordered pair. What is the third ordered pair? Ordered pair A comma C, also in the relation R. We have shown this one. Yes or no?
Yes, sir.
Therefore, we say that R is symmetric. Sorry, R is
Transitive, sir.
transitive relation. So, by following these steps, by following these procedure, we can show that we can check, we can verify the given relation R is reflexive, symmetric, or transitive. For the previous questions, elements are given directly, so it is very easy to identify ordered pairs. Yes or no? But in this case, this is a second case. Here, domain is not a finite set. It is an infinite set of integers. A relation R is defined on an infinite set. In that case, we follow these steps. Okay, my dear children.
Okay, sir.
Similarly, we will try the Roman number 5 questions. This is the first Roman fourth question. Will you try the first Roman fifth question? In that fifth question, A, B, C, D, E are there. Will you do that sums as homework?
Okay, sir.
If you have any doubt, feel free to ask your doubts in solving the given homework sums. Okay. Homework is page number 5, question number first Roman fifth. Means A, B, C, D, E. Total five sums are there. Will you submit these homework sums tomorrow?
Yes,
Okay,
sir.
sir.
If you have any
Okay, sir.
doubts, remaining sums also same like these questions, same like this question. Okay, try the questions. If you have any doubt, feel free to ask your doubts and get your doubts clarified. Just orally, let us discuss what is the first relation. X and Y. See the first relation. Fifth Roman A. Question number A. X and Y work at the same place. X and Y work at the same place. To check the relation reflexive, how do you write that sentence? X and Y work at the same place. How do you write? To check the relation or reflexive, we have to choose an arbitrary element, A. Okay. So A and A work at the same place. We get like that statement. We get that statement. A and A work at the same place. Is it a true statement or wrong? Wrong statement. A and A work at the same place. Is it a true statement or false statement?
False, sir.
False. A and A work at the same place.
True, sir.
Yes, it is a true statement. Ram and the same person, both are working at the same place. Means the person is the same only. Same person is working in the same place. So it is a true statement.
Okay, sir.
Next to symmetric, X and Y work at the same place. If you write its reverse order, for example, uh, Greason and Stein-Janssen are in this meeting. If you write in the reverse order, Stein-Janssen and Greason are in the meeting. True statement or false?
True, sir.
True, sir.
If
True,
if
sir.
if Greason and Stein-Janssen are in this meeting, I'm writing in the reverse order. Stein-Janssen and Greason are in the meeting. True statement or false?
True, sir.
True statement. Similarly, here also, X and Y work at the same place. If we write in the reverse order, we get a statement as Y and X work at the same place. It is a true statement. So we say that it is a symmetric. Similarly, to check transitive, we have to choose three numbers, arbitrary numbers, X, Y, Z, or A, B, and C. X and Y work at the same place. Suppose Greason, Stein-Janssen, and Joseph. These three students are attending the meeting. If we say that Greason and Stein-Janssen attended the meeting, Stein-Janssen and Joseph attended the meeting. Can you say Greason and Joseph attended the meeting or not?
Yes, sir.
As true statement. Finally, we get a true statement. So in that case also, we say that it is a transitive. In this way, we have to check the remaining relations also. We have to use some common sense. Okay, some common sense also should be used here. Some thinking skills also important here. Okay, my children.
Okay, sir.
Write this classwork notes. Write this classwork notes. I am giving hardly 5 sums. Hardly 5 sums per a day as homework. Please finish that homework and submit your work in the Google Classroom.
Okay, sir.
I will post this work in the form of PDF as for the previous classes as I posted. For this also, I post this classwork notes in form of PDF, and I will post the video also. Okay, for your reference.
Okay, sir.
Okay, sir.
Now the time is 12 past 2 minutes. Now you can leave the meeting, my dear children.
Thank you,
Take
sir.
care of your health.
Thank you, sir.
Stay at home. Stay safe. Use mask. Use sanitizer, and
Thank you, sir.
maintain social distance. Okay, my children.
Thank you, sir.
Thank you. Thank you all.
Sir,
Yes, my dear Preetika.
sir, I
What's-
have doubt in previous homework sum, sir.
What's your doubt?
Sir, in first question you have said that it is not reflexive. It is not reflexive, sir. But we have 1, 1 and 3, 3. So how it will be not reflexive, sir?
1, what are the elements in the domain? Tell me.
1, 1, 2, 1, 3, 3, 3,
I'm
2, sir.
asking elements in the domain. What are the elements in the domain? I'm
Sorry,
not
sir.
asking
1, 2, 3 and 3, sir. Sorry, 1, 2, 3, sir.
1, 2, 3. You should get 1, 1, ordered pair 1, 1, ordered pair 2, 2, ordered pair 3, 3. All these three ordered pairs should be in the relation R. Only in that case we say that R is said to be reflexive. If any ordered pair is missing, then the relation R is not said to be reflexive.
Okay, sir. Sir, then also for second question for the first number, you have said that it is reflexive, but we have like 1 comma 1, 2 comma 2, and 3 comma 3, sir.
Which question?
Second question, sir.
Second question. Y is
Second,
equal to X. Y
second
is equal to
question, first one, sir. R1 in homework sum.
in homework.
Yes, sir.
What is the question there? Tell me.
Sir, you have given three under second question. You have given three Romans, sir. Like R1, R2, and R3. We have to
Uh,
find the uh, types
check.
of sets, sir. Yes, sir. We have to check. For
Uh,
that, you have given reflexive for the first one, sir.
okay. What is the set domain?
1, 2, 3, sir.
1, 2, 3. In
Yes, sir.
R1, in R1, which ordered pair should be there to be reflexive?
1 comma 1, 2 comma 2, 3 comma 3, sir.
Are these three ordered pairs there or not in the relation R1?
It is there, sir.
Then we say that it is a reflexive. There may be more
Okay,
than
sir.
that ordered pairs. It doesn't matter.
Okay, sir.
We doesn't concentrate. We don't concentrate on that remaining ordered pairs. Whether
Okay,
these
sir.
twins are there in the relation or not.
It is
Whatever the
there, sir. It
elements,
is there.
whatever the elements in the domain, twins should be there for every element. Clear?
Okay, sir. Yes, sir.
R2, is it also clear?
Yes,
R2.
sir. Those are clear, sir. Only first and second one I had doubt,
Uh,
sir.
so if any elements are there in the domain, twins should be there. There may be more than the ordered pairs, but
Okay, sir.
twins should be there. The first primary condition is twins should be there.
Sir, it
What
is
are the
also
elements?
for symmetry and transitive, sir. Like all the domains should be there for symmetry, then only
No,
it
no,
is
no, no, no,
symmetric, sir.
no, no, no. Only in the case of reflexive. Only in the
Okay,
case
sir.
of reflexive you should consider. But in the case of symmetric, we should not consider elements in the domain. We should consider only ordered pairs in the given relation. If 2 comma 3 is there, 3 comma 2 should be there. That's all.
Okay, sir.
If we concentrate on ordered pairs which are given in the relation, in the case of symmetric and transitive,
Okay, sir.
you should not concentrate on the elements in the domain. Only in the case of reflexive, we concentrate what are the elements given in the domain.
Okay, sir.
That the twins should be there. That is only the first point. Okay.
Okay, sir.
Okay.
Understood, sir. Thank you, sir.
Okay. Carry on. Carry on. What, my dear Joseph? Still you are in meeting? You also can leave.
Okay, sir. Thank you, sir.
Any doubt? You have any doubt? Just you are listening. Doubt?
Yes, sir. I am listening the doubts, sir.
Very good. Very good. Very good. Okay. Is it clear for you that the doubts also?
Yes, sir.
Okay. Okay. Carry on. Carry on.
Thank you, sir.
Okay.